Hey guys, if you want to just take out your sequences packet, it says recursive sequences on the front. We're going to just talk about the beginning of this packet in this video. Alright, so first thing we're going to talk about is a recursive sequence. Now, a recursive sequence is just a sequence of numbers that uses the previous term to help you come up with what the next term is going to be. Alright, so this is how it works. If you guys take a look at number 1, it asks you to find the first 4 terms of the recursive sequence to find below. Alright, so it tells us here, when it says this, a sub 1 equals negative 3, well, that's your first term. So the first term is done for us. Alright, I'm going to make kind of like an answer box off to the side here. So the first term we're going to call a sub 1. Alright, and we already know that's negative 3. Now we still have to find the second term, which is a sub 2, the third term, which is a sub 3, and the fourth term, which is a sub 4. Okay, so these little numbers are just subscripts. And I'm going to box that up. That's where our final answer is going to go. All right, now, we're going to use the formula they give us here for, this says a sub n equals a sub n minus 1 minus n. We're going to use this formula right here to help us find the next 3 terms. All right, so let's start off with a sub 2. All right, so a sub 2, well, let me write this formula first. A sub n equals a sub n minus 1, and then it says minus n. All right, now if I want to find the second term, what I'm going to do is I'm going to replace this n right here with a 2. So we could write a sub 2. Now if I replace that n with a 2, anywhere I see an n, I'm going to have to replace it with a 2. So I'll have a sub 2 minus 1, and then minus, well, I see another n, so I'm going to have to replace that with a 2. Now keep in mind, I know it's kind of sloppy on this, but these right here are subscripts. This is not. Okay, you can see where it's typed up right here, right? The n and the n minus 1 right here, these are subscripts, but everything else is not. All right, so let me bring down the a sub 2. This means the value of my second term is equal to. Now, since 2 minus 1 is just 1, I'm going to just for right now write this out as a sub 1. Okay, again, I'm just doing 2 minus 1, and then I'll bring down this minus 2. Okay, so a sub 2 is equal to a sub 1, they gave us, right? They told us that a sub 1, here it is, right here, is negative 3. So I'm going to go ahead and replace this a sub 1 with a negative 3, and then I'll bring down my minus 2. And since negative 3 minus 2 is negative 5, a sub 2 is equal to negative 5. All right, so we can put that in our answer box right here, negative 5. We found the next term. All right, so now let's go ahead and let's do the same thing. Let's repeat that same process to find the third term, so a sub 3. All right, so I'm going to do it right underneath this formula here. So I'm just going to write a sub 3 equals. Now, if I replaced this n with a 3, anywhere I see an n there and there, I'm going to have to replace it with a 3. So I'll write down a sub 3 minus 1, and then minus 3. Okay, so a sub 3 is equal to, well, since 3 minus 1 is just 2, this is really just going to say a sub 2. And I'll bring down my minus 3. Okay, so a sub 3 is equal to, a sub 2 we found right over here, or even if you want to look in your answer box, a sub 2 is equal to negative 5. So I'm going to replace this a sub 2 with a negative 5. And I'll bring down my minus 3. So I'll have a sub 3 equals negative 5 minus 3 is negative 8. So this is the value of our third term. So I'm going to put that in my answer box right here. Okay, and then finally let's find a sub 4. So same thing over and over again. So a sub 4, so if I'm replacing this n in the formula with a 4, I'm going to replace this n right here with a 4, as well as this n right here with a 4. So it'll say a sub 4 minus 1, and then minus 4. So a sub 4 minus 1, and then minus 4. All right, well, since 4 minus 1 is 3, a sub 4 is equal to a sub 3 minus 4. All right, so a sub 4 is equal to the answer to our previous term, which is right here, negative 8. So let's replace the a sub 3 with a negative 8 and bring down the minus 4. And since negative 8 minus 4 is negative 12, that's the value of our next term. Okay, I mean, if you look over here, you'll see there's a pattern, right? Like you're basically just, it's going down by 2. It's going down by 3. It's going down by 4. It's going down by the number of the term that you're on. So if you wanted to find a sub 5, right, it'd be taking the previous term and subtracting 5. So a sub 5 would be negative 17. Right, and that's what this rule says. It says to find whatever term you want to find, take the term before it, right? You're taking n minus 1. You're taking the term before it, and you're subtracting the value of the term number that you're on. So if I wanted to find a sub 8, I'm doing a sub 7 minus 8, minus the number of the term that I'm on. Okay, so number 2 says find the third term in the sequence, in the recursive sequence, and they give us our rule right here, and they're telling us our first term is 3. So when you're given a recursive sequence, they do have to tell you the value of one term because you need to use that term to help you find the next term and, you know, the term after that and so on. All right, so they only want us to find the third term. So the answer to this question is going to be whatever the value of our third term is. All right, well, we know the first term, so let's find the second term. All right, so we're going to first find a sub 2. Now, let's think about this. If we want this subscript to be a 2, well, this says, instead of using n, this time they're using k. This says a sub k plus 1. So if we want this to be a 2, then wouldn't k have to be 1? Isn't 1 plus 1 2? Okay, so really, if I want to find a sub 2, anywhere I see a k, I'm replacing it with a 1. So if I replace this k with a 1, I have to replace that k with a 1 as well. So this is going to be equal to 2 times a sub 1 minus 1. So a sub 2 is equal to 2 times a sub 1 minus 1. Okay, again, I'm just going to reemphasize. How we got this 2 is by replacing this k with a 1, right? Because 1 plus 1 is 2. So if we want this to say a sub 2, we're going to replace a k with a 1. All right, so a sub 2 is going to be equal to 2 times a sub 1. Okay, well, we know a sub 1, they gave it to us, is equal to 3. So I'm going to replace that a sub 1 with a 3. And then I'm going to bring down my minus 1. All right, so a sub 2 is equal to 6 minus 1, which is just 5. So our second term, the value of our second term, is 5. Now, that's not our answer, though, because they want us to find a sub 3. So let's do the same thing. Since this says a sub k plus 1, if I want this subscript to be a 3, well, then k has to be 2, because 2 plus 1 gives you 3. So if I replace this k with a 2, I have to replace this k with a 2. So this will say 2 times a sub 2 minus 1. So 2 times a sub 2 minus 1. Okay, so a sub 3 equals 2, and I'm going to replace the a sub 2 with what we got a sub 2 to be equal to, which is 5. And then I'll bring down my minus 1. All right, so that gives us a sub 3 equals 10 minus 1. And since 10 minus 1 is 9, a sub 3 is equal to 9. This is our answer here. They wanted us to find the value of the third term, so there we go. All right, so let's take a look at number 3. It says, while experimenting with her calculator, Candy creates the sequence 4, 9, 19, 39, 79, and so on. Okay, write a recursive formula for Candy's sequence. Determine the 8th term in Candy's sequence. Okay, so if we want to write a recursive formula, there's 2 things we need to include. We first need to include what a sub 1 is equal to, or at least one of the terms. It doesn't have to be a sub 1. It could be any of the terms. And then we need to create a rule that helps us find all remaining terms, or any, all terms from that point forward. Okay, so I'm going to start off, and I'm going to say, they show us right there the first term in her sequence is 4. So I'm just going to write a sub 1 equals 4. Now, I like to use the variable n for my subscript, but you can use whatever you want. All right, so I'm going to say a sub n equals. Now, I need to kind of make a rule that'll, that you can use to find any term from this point forward. So if we look at our sequence, let's just kind of figure out what's going on here. So if we're starting off with a 4, and then from there we have a 9, and then a 19, and a 39, you kind of have to look and say, well, what pattern is going on? What's happening to get from one number to the next? Well, hopefully after kind of looking through this a little bit, you realize that what she's doing is she's doubling the previous number and just adding on 1, right? Because if you do 4 times 2 and add on 1, it gives you 9. If you do 9 times 2 and add on 1, it gives you 19. 19 times 2 plus 1 would be 39, and so on. So if we want to make a rule for this, we could say she's doubling the previous term and then adding on 1. So to come back over here, if we want to say a sub n, if she's doubling the previous term, she's doing 2 times the previous term. Now the previous term would be a sub n minus 1. If you want to put that n minus 1 in parentheses, you can, but you definitely don't have to. Okay, so anyway, what she's doing is she's doubling the previous term and she's adding on 1 to that. So just to kind of double check and make sure we have this right. Okay, so if we wanted to find a sub 2, if we wanted to find the second term, right, if I replace that n with a 2, 2 minus 1 is 1. So we'd be doubling a sub 1, we'd be doubling the first term. So 2 times 4 is 8, plus 1 is 9, and that is the value of our second term. If we wanted to find a sub 3, okay, let's replace this n with a 3. So 3 minus 1 is 2. So we'd be doubling the second term and adding on 1. If we double the second term, so the second term is 9. If we double 9, 2 times 9 is 18, plus 1 is 19, and that brings us to the third term. So this right here would be the rule. That would be a recursive formula for Candy's sequence. Now, it says to determine the 8th term in Candy's sequence. I mean, you could go through and you could just keep using this rule, but I almost feel like it's easier at this point to just kind of follow along with our sequence. Like, here's your first term, here's your second term, here's your third term, here's your fourth term, here's your fifth term. So if we want to find the 6th term, we would double the 5th term, so double 79, and you would just add on 1. All right, so 2 times 79 is 158, and 158 plus 1 would be 159. So that's our 6th term. If we want to find our 7th term, we could do 2 times 159 and add on 1. So 2 times 159 is 318, and 318 plus 1 is 319. And then finally, this is what they're looking for. If we want to find the 8th term, we're going to double the 7th term and add on 1. So 2 times 319 would be 638, and 638 plus 1 is 639. So this right here would be a sub 8th, which, in other words, just means the answer to the 8th term, or the value of the 8th term.